I want to show some of the things we're competing against, just to give it in a frame of reference. So in these applications where we're trying to precipitate iron and manganese, we've got these draft aerators out there that basically use the height and the cascading effect of water to flow and mix with air to put them in. But you can see they take up a lot of space. They're pretty high. You have to work on them. They get fouled. And so we think our system is a lot better. So this is what it looks like when they're brand new. But I like to show what it looks like in a real situation. Now, you don't get too much snow in India, but you can just imagine when someone has to work on these things in a cold weather environment, and they've got to climb up on the top of these things. They've got to take out all the different media that creates this cascading effect. And so, you know, our solution is a lot better. It's just a pump. And I'll show the animation in just a second, and you'll see how much less maintenance there is for something that you're looking at versus a draft aerator. So this is the animation. What happens is basically that's the main flow, and you're taking a side stream through that pump. It's maybe about a 10% side stream. And then you pump up, and basically for a venturi, you have to create the pressure differential across that venturi. And then the mixed gas that you're pulling in, now you're mixing that back in, the 10% high concentration of gas liquid flow back in with these specially designed nozzles that mixes in this water gas mix so that you get this homogeneous mix and you get as much gas dissolved in as possible. Typically about like 95% mass transfer for the gas liquid, which is pretty high compared to a lot of the other technologies. And so here's a small version of that pipeline flash reactor. This is an application where they were going into a river or a lake or a creek where they needed to get the dissolved oxygen up, because in the United States, there's a lot of requirements that you can't put low oxygen into a receiving water, like a river, a creek, a lake, because what happens is you kill the fish, the wildlife, and you create these zones where you have algae, and so they really need to get the dissolved oxygen up. So these are a system, a series of pipeline flash reactors and venturi. You can see the venturi on the bottom of this photo in the skid. Very simple. You can see just a pump, a venturi, and then these systems there. So it's a compact footprint. You get very rapid oxygen transfer in just a couple of pipelines in the system. Low maintenance. It's quiet. A lot of times if you're using blowers or these diffusers, you get a lot of noise. You've got to protect the diffuser, the blowers in some kind of housing. And as I said, no diffusers and no basins. So you're talking about a lot less civil works. If you're doing it in a pipeline, you don't have these basins that can take a lot of steel and concrete. And then I wanted to show, we showed a small one. This is one of our biggest pipeline flash reactors. That's the owner, Angelo Masi, standing there. You can see how big this system is. This was for a system in California for disinfection of drinking water using ozone. So you can see the size range that we produce, the smaller ones for some small applications, and then this large one. And then for basin nozzle manifolds, if you want to have a basin, we do the same kind of design, where instead of the pipeline flash reactor, we're using the basin, and I'll show this one. So here's an animation of the wastewater aeration without blowers. And basically what you're doing is, again, you're using a pump, and this pump can either be in the basin or outside the basin. It doesn't really matter. You're flowing up through the venturi. Again, the venturi action is you need a pressure differential, but you're pulling in the gas. through the venturi, mixing it, and then you're coming back around and you're using those specially designed nozzles, not only to mix back the water, but you can see the flow. And they create a good mixing pattern in the basin. And if you compare it to fine bubble diffusers, you don't get that mixing with the fine bubble diffusers. So a lot of times, the extra energy you use, the pumping energy, you can actually use it so that you're getting more mixing, and you can use a lower height of the basin as opposed to the base, the nozzles. So it's, as I said, low maintenance, very quiet. There's no depth limitations. In fact, we like the deeper the better, because then you've got the head of the tank pushing against that pump. And so you got some advantages that you don't have to have as much pumping power. It's more efficient mixing, as I mentioned, and it maintains the water temperature.